Hey everybody, we are starting section 2 in chapter 8. Today we're talking about arithmetic sequences and partial sums. So let's talk about what an arithmetic sequence is. Arithmetic sequence is a sequence where the differences between consecutive terms are the same. So when you think of arithmetic, if they have a consistent difference, think adding the same number is the pattern. So let's define the common difference of an arithmetic sequence. So a common difference, we call that D. So common differences, we call that D for the letter, is any term, so we'll call it maybe the second term, subtracted by the term in front of it will be the common difference. It would also be the same as if I took the third term and subtracted the one before it, or the second term. Or, you know, any term minus the term before it. Okay, so let's determine whether or not this sequence is arithmetic. Okay, so any time, basically we can kind of look at this pattern. What's going on here? So I see from here to here, I'm adding a -4. I'm also adding a -4. I'm adding a -4, adding a -4. Another way to double check that is like, okay, if the second term minus the first term is 7 minus 3, that's 4. That the fifth term minus the one before it, is it also 4? Let's see, -9 minus -5 is -4. Oh, I did this wrong, by the way. This should be 7 minus 3, pardon. So both are common difference, though, therefore, yes, it's arithmetic. Meaning it has the same pattern where we're adding the same value. The nth term has this form. So any nth term of an arithmetic sequence is equal to the first term plus the n, which is the number of the term that we're looking for, minus 1 times the common difference, where D is the common difference between consecutive terms, A1 is the first term of the sequence. So let's find a formula for the nth term of the arithmetic sequence whose common difference is 2, so that's D is 2, and the first term, or A1, is 7. So remember, we're going to use this formula up here where we say the nth term equals the first term, A1 is 7, plus n minus 1, we don't know what n is, times D, which is 2. So if I want to simplify this, I know just like, you know, in algebra, I can distribute this into that product and we get 7 plus 2n minus 2. And we end up with a simplification of 7 and -2 are 5 plus 2n. So we can say the nth term equals 5 plus 2n, or you can say 2n plus 5. When you know the nth term of the arithmetic sequence and you know the common difference of the sequence, you can find the n plus 1 term, meaning the next term, by using the recursion formula, which here's the recursive formula. Remember, recursive just means to look back. We can take some term, it equals the previous term plus the common difference. Okay, so we say a term equals the previous term plus the common difference. Okay, let's go to example number 3. It says find the sixth term, or a sub 6, if the arithmetic sequence that begins with 15 and 12. So here's my first term is 15. My next term is 12. And they want us to find the sixth term. So keep in mind, any nth term of an arithmetic sequence is the first term plus n minus 1 times D. So first things first, let's go ahead and write our nth term. So we know our first term is 15. We can plug that in here, plus I don't know what n is yet. We will find it pretty soon. We know our common difference if we take the second term and subtract our first term, we say the common difference is going to be -3. Plug that in right here. Is our nth term. Well, we know our nth term, instead of finding the nth term, is 6th term. So when n equals 6, we say 15 plus 6 minus 1 times -3. Simplify that, we get 5 times -3. 15 plus -15 is 0. So our 6th term is 0. Let's talk about the sum. So remember, sum is adding everything up of a finite or ending arithmetic sequence, okay? So the sum of a finite arithmetic sequence says this capital S of the nth, meaning ending term, is n divided by 2 times the first term plus whatever the ending term is, the nth term, okay? And the sum of an infinite sequence, so infinite sequence, sum of the infinite, meaning this isn't going to end, we say is the nth partial sum. Okay, so let's find the sum of the first 20 terms. So this is a finite sequence ending at the 20th term, where a sub n equals 28 minus 5n. So remember, this is going to be a sum of the 20th term equals n over 2 divided by a1 plus an. Well, we know, remember, n is 20, so we're going to say this is 20 over 2, but we need to find the first term. So we don't know it yet, but we know that this can find me any nth term in the sequence. So if n equals 1, then we say 28 minus 5, where n is 1. So 28 minus 5 times 1 is 5, so that's 23. So the first term is 23, so we're going to replace that right here. And we're going to add where n is 20. So n is going to be 20 here. Let's find the 20th term. So instead of having to multiply out this pattern, we're going to write 28 minus 5 times n, where n is 20. So it's 28 minus 100. That gives us -72. Put it right here instead of the 20th term. And if we add this up, we know 20 divided by 2 is 10 times 23 minus 72, or plus a -72, is -49. And we get a total of -490. So our sum to the 20th term is -490. All right, that's it for today. See you back in class.